temporal resampling. In this tutorial, I'm going to show you how to better visualize information, in this case on a daily basis instead of hourly, where all the data is bunched up and we can hardly see the differences. So, starting from our data, we are going to see with the resample function, which asks us for the rule parameter. The values we have to pass are given by the date offset, which is a list of temporal parameters that comes from Pandas, as explained in this link. Below, we are given a list of all the types of temporal intervals we can use to summarize the information. It tells us, for example, every business day, every custom business days, every week, every month, every start of the month, etc. In our case, we can also go with intuition and tell it that we want to aggregate it for each day, as day in English is D. We put a D and execute. Here the result does not appear yet. The only thing it tells us is that the object returned by the function is a date-time index resampler. It is holding that aggregation of data on a daily basis among all the hours we have in our table, and waiting for us to give it a mathematical function to perform the calculation. If we apply the sum and execute, we see that we have gone from having the data on an hourly basis, which were 8,000 hours, to having 365 days. And now, when I visualize the data with the plot function, we see that the differences can be better appreciated instead of, as we did before, where all the hours were bunched up. An extra concept you can learn from this line of code is dot notation and the chain rule. That is, it might sound very strange that I have concatenated all the functions one after another, but this is possible in Python, because if the object returned by this function, which we saw here above, can use the plot function afterwards, then there is no need for me to save that result and then have to apply the function I want. I could directly apply that entire line of code and execute the graph I want, although both options are equally valid. And as you know in this code, for now, to each their own. Well, now we can aggregate the data on a monthly basis. The only thing we are going to have to change here is that instead of putting the day, we are going to put the month. And now the data appears differently. I could have even told you earlier, which we haven't covered, every 7 days, for example. And here we see another distribution of the data. We could also say every week with a W, and we see it appears the same because it's the same calculation. Continuing with the month, we can try other types of graphs, for example, area charts. If I save all this result in a variable to see it better, let's call it, for example, S. And now I call the function and I get a line, but notice that if I hit the tab and go to plot, it puts here on the right instance. That is, I could keep diving in and see the types of elements I can play with in programming. For example, I can make area charts, we can also make bar charts and so on, with all the functions you see in this battery of functions. Although it is true that depending on the type of data you have, some functions are not applicable. In the following tutorials, I will go into more detail with the types of visualizations ideal according to what type of data. Now, what you need to understand from this tutorial is that instead of having the raw data with the default interval, in this case, hourly, you can use the resample function with any of the temporal aggregations that appear on this website, and that you can also use different types of charts that come from the Pandas library to, instead of visualizing the data numerically, do it visually through charts. And now let's go to the next chapter where I'm going to teach about pivot tables. That is, instead of having the data in a single column, we will summarize it to see what happens at each of the hours for each of the months.